Hello, welcome to class. We have our fifth practice question and it's still on circle theorems. We are told that BD in the diagram, that is this diagram that we have here, is BD is the diagram of a circle center O. C and A are 2 points on the circle. C and A are 2 points, and AB and DC produce to meet at E. Then we are told that angle AOB, that is this angle at this center, is 110 and BDC is 23. We have to find ADO and BAC. Now, what can we do? Let's quickly look at what we have and what we need. We need ADO, and where is ADO? ADO is here. ADO, that is this angle that is here, is what they ask us to find. ADO. And as well, let's start with ADO first. We asked to find this angle. So what we could do is try and look for things that can relate to ADO, I mean, from the values that we have. So one major thing I want us to first notice is that we notice that any line drawn from the center to touch the circumference is a radius. This is also a radius here. So this radius and this radius is the same. They are both the same. So it makes this triangle an isosceles triangle. So if you follow the previous video as well, you notice that this is also very common in my statements, that when you have radius, automatically the base angles are isosceles triangle. Now, if they are both isosceles triangle, then I know that ADO is the same thing as saying OAD. That is, this is equals to this. They are both the same. Now, let's note that. Then you also observe here that here is 110 degree. Then I can find this place because this is a straight line. This diameter here is a straight line. So if this part of this straight line is 110, then this other side will be what? 70, because 70 plus 110 will give me 180. So here will be 70. So I know here is 70. Then I know these two, they are both the same. So I can make here x. If I make here x, this is also x. X plus x, that's 2x. Then 2x plus 70 equals to 180. Sum of angles in a triangle. Then I'll get the value of ADO, which is x. So let's put that into writing. So we want to look for ADO. Then we've just established that these angles are the same. So we can say that for ADO is equals to OAD, that is OAD, which is equals to, okay, they are both the same. Then we can say base angles of isosceles triangle. They are both the same. Now we can as well make them x. But before then, let's quickly find the value of this other side. So we'll say that AOB, angle AOB plus DOA equals to 180 degree. What we mean by that is DOA, that is this angle here. Sum of angles on the straight line, these two angles, will give us 180. Then from there, not to waste our time, we automatically know that DOA is 70 degree. Sum of angles on a straight line, because if we deduct 110 from 180, we have 70. So this DOA now is 70 degree. Then we can add 70 plus x. Since they are both the same, we can say that 70 degree plus ADO plus OAD is equals to what? 180 degree. Angles in a triangle. So what we mean by that is this plus this plus this will give us 180. Then we know they are both the same, so we can make them x. So this will give us 2x equals to 180 degree. Then x will give us 180 degree minus 70 divided by 2, because you divide this by 2 when you take this here. Then we'll have 180 minus this, that's 110. Then 110 divided by 2 give us what? 52 degree. So since we said both x, let me make ADO and OAD x, so that we can add them together. Then we can say x, which is what? ADO. So x equals to ADO, which is equals to what? 55 degrees. So we found the value of ADO. So let's find the value of BAC. Now, to do BAC, we need to observe another thing here. This is where BAC is. BASC. So look for theorems that relate with BAC. What we could do, right? So based on the theorems that we've treated, if you look at this, it looks like angle in the same segments are equal, because it's coming from here. It's forming an angle at the circumference here. That's 23. And also from here, it's also forming this angle CAB or BAC. This angle here. So we can say that angle in the same segment are equal. Then this angle here is equal to this angle here, not this one. This angle that is here, that's angle BAC. So we can say that CDB equals to BAC, which is equals to 23 degree, angles in the same segment. That's the theorem. Then we can say that, so therefore BAC is equals to 23 degree. We've just found ADO and BAC using the theorems that we have treated so far.